How's it going, guys? So today we're going to talk about a couple things. We're going to talk about the fundamental theorem of algebra. We're going to talk about complex conjugates too. Okay, so complex conjugates get a little difficult. They get a little bit fun though when we're talking about, say, finding an actual function, a polynomial function in which we're going to have some complex numbers as our answers, and try to actually figure out what those functions are. So first thing, the fundamental theorem of algebra states that for every, say, exponent we have, so for every polynomial, if I have f of x is equal to 6x to the 7th plus 7x cubed minus 3x squared plus 2. The fundamental theorem of algebra says that the highest exponent I have, that degree, tells us how many possible solutions we have. So in this case, I have 7 possible solutions. They don't all have to be real, they don't all have to be rational, but I have 7 possible solutions, okay? So in this case, h of x is equal to 2x squared plus 3x minus 1. Now, I have how many possible solutions here? 2. I have 2 possibles. That doesn't mean they have to be real, though. None of them have to be real. I could have repeated solutions, but I have set 2 possible solutions in these cases. This case would have 7 possible solutions. Okay, how about this one? We'll go j of x is equal to x plus 2 squared times x minus 1 cubed. So we already know what the solutions are. We know they are negative 2 and 1. So we have 2 solutions. But with there being 2 x's here, 3 x's here, we have 5 possible solutions in general, okay? So we have 5 possibles. But actually, we only have 2. Unfortunately. So that'll help us out when we're talking about some, say, rational root theorem problems. So if I have a problem that looks like this. F of x is equal to x to the 5th plus x cubed minus 2x squared minus 12x minus 8. And I ask you guys to try to figure out this. Let's figure out the zeros in this case. Set this equal to 0, find the factors here. Okay? So factors first are 1, 2, 4, and 8. Factors here are just 1. So the possible rational roots are going to be plus or minus 1, 2, 4, and 8. Which means I have to use my synthetic division with 1, positive 1, negative 1, positive 2, negative 2, positive 4, negative 4, positive 8, negative 8. And I have 5 possible solutions. Okay, so when I do this, synthetic, 1, coefficients here are 1, 0, 1, negative 2, negative 12, negative 8. Bring in the first one, 1, 1, 1, 2, 2, 0, 0, negative 12, negative 12, negative 20. 1 didn't work. We'll try negative 1. 1, 0, 1, negative 2, negative 12, negative 8. 1, negative 1, negative 1, 1, 2, negative 2, negative 4, positive 4, negative 8, positive 8, and 0. Okay. So we know negative 1 is a solution. So I know it's going to be x plus 1 times something. So it's going to be this. This gives me constant, linear, quadratic, cubic, quartic. So I have x to the 4th minus x cubed plus 2x squared minus 4x minus 8. And we have to use synthetic again. We don't have to check 1 again because we know it's not a solution. But we can check negative 1 again to see if it is, because it could have a repeated answer here. So let's do that real quick. So I'm going to check negative 1 again for here. So my coefficients I'm going to write down. I have 1, negative 1, 2, negative 4, look here, I'm saying, okay, bring down my 1, multiply these, add these, multiply these, add these, multiply, add, oops, this should be negative 2, this should be positive 2, that should be 4, negative 4, negative 8, positive 8, and 0. Okay, so I have a repeated solution at 1 then. So I have x plus 1 times x plus 1, or x plus 1 squared, times, this gives me my constant, my linear, quadratic, and cubic. And I look at this problem, and I say, okay, I have a cubic here. I could actually try to factor by grouping. So I'm going to group these first two together. Actually, this is going to be 2. I'm going to factor those first two together, factor out an x squared times x minus 2. Factor out a 4 here, x minus 2. These are the same thing. So grouping is definitely going to work. What I end up with is x plus 1 times x squared plus 4 times x minus 2. So all of my solutions here are x is equal to a negative 1, but that's repeated. X is equal to, this is going to give me the square root of a negative 4, which gives me 2i. This will be plus or minus 2i. If you don't know, set this equal to 0 and then solve for me, please. And this gives me a x is equal to 2. So I have the repeated answer here. I have 2 answers here. I have 1 answer here. Gives me my 5 possible answers to this problem. Now, this will happen all the time. You may have to use synthetic a couple times, but the process is not hard. The process is not difficult. But say we already have those solutions, and we want to come up with a function which is a polynomial with those possible solutions. All we have to do is multiply those back out. So say I have my answer being 3, negative 1, and the square root of 5. Okay. There's something called the complex conjugate theorem. Okay. Well, the complex conjugate theorem states if you have a complex number as your answer, the opposite of it is also going to be a solution. So if I have, say, a plus bi, or a plus the square root of 5, then a minus bi, or a minus the square root of 5, these are all going to be the same. So a conjugate of it, for any complex number, is going to be a solution also. So a plus bi and a minus bi, in this case, it's going to be the square root of 5 and negative square root of 5 should both be solutions to this problem. Okay. So what we're going to do, actually I'll just change this to 3 plus 2i. So what we're going to do is try to find a function that actually has these as zeros. What I need to do is say x minus 3, x plus 1, x minus 3 plus 2i, and 3 minus 2i, x minus 3 minus 2i. So I need to multiply this out, distribute this out. This gives me x squared minus 2x minus 3 times x squared. This is going to give me 9, and this gives me 4. My middle terms will cancel off because these are going to be conjugates. All I did was multiply the conjugates together, and that's what it's going to give me. So x squared plus 9 plus 4 gives me x squared plus 13 times x squared minus 2x minus 3. If you don't know how I got this, please distribute the negative sign, and then triple distribute both of these. So you're going to have to multiply everything out and then combine all your like terms to get this as your answer. Distribute this out. I get x to the 4th plus 13x squared. I'm going to get negative 2x cubed minus 26x. Then I'm going to get negative 3x squared minus 39. Combine like terms. I have like terms here. And that's it. 1, 2, 3, 4, 5, 6. Okay. I have x to the 4th minus 2x cubed plus 10x squared minus 26x minus 39. All it is multiplying things out. Group your first two together first, multiply. Group your second together and multiply. And that's it. That's all you have to do. You don't have to do anything else there. So after you multiply these out, multiply that answer out, that's what you get. Nothing else, no extra stuff, just straight multiplication. If you guys have any questions, you guys know how to contact me. Have a good one.